In Refraction of Light, the learner is going to have an opportunity to investigate the refraction of a beam of light through a Perspex block and even through a trough. You're going to need a 12-volt power source, the light box, and in that you're going to put a gate with one slit, and those just slide in, and then this slides back into the box. Do warn the learners that this can get quite warm once the light has been on for a while. And while the investigation is taking place, you're going to need to dim the lights so that you can actually see the beam of light clearly passing through the block. Then what the learners are going to do is place the Perspex block on a piece of paper, turn the light on, and then observe, with the lights a bit dimmed, that ray of light as it hits one of the long sides of the block at a bit of an angle, and they can start off at quite a narrow angle and then slowly increase it until it is going straight through the block, and then observe the changes that they see. Then what they're going to do is place the block in the center of this disc that shows the different angles, and they're going to, the nice thing about this disc as well is that you would usually draw a normative line, or the norm, perpendicular to the block, and if you place the block carefully on here, you have that constantly there, so you can shine that light and change the angle as it hits, the incident ray hits that side of the block, and see the change in angles over there, the difference. And then once they've experimented over there and they've had a look at it, then they can place some water in a trough, and they can see the incidence and refracted and emergent ray of light through that trough of water. So what I'm going to do now is dim the lights a bit, and then we're going to have a look at this. Right, so we want the learners to observe the incident ray coming into the Perspex block, being refracted from the point of incidence, and then traveling through the block and emerging out, the emergent ray coming through. So the incident ray, refracted ray, and emergent ray. And then they can shift the block to see how those angles change as the block shifts. Now, to get a more specific reference point, we'll use block on this protractor, and then what we're going to do is keep that ray of light, the point of incidence on. We're going to use this reference here, which is at 90 degrees to the surface of the block, as a normal. So then as I shift that, I see I've got a small angle of incidence, and then I can see off the back of the block here, I can see that angle of refraction. And as that angle of incidence gets larger, the angle of refraction increases as well. And later we will use that for Snell's law. Once they've been able to observe that, we can take our little tub over here, fill it with water, or half fill it with water, and then they can observe that water also refracts light. Here they have the incident, refracted, and emergent ray. And then you can talk about practical applications of that, for example, seeing a fish underneath the water, and if they observe that the fish looks like it's in one place, the fish is in fact further up or further down from where they observe seeing it, if they're looking at the water from an angle. I hope you enjoy using the kit and continue to observe.